All right, let's just jump right in. We live in a world that is completely built on software. I mean, think about it. Your phone, your bank, even the power grid, it's all code. And we just, we trust that it works. But here's the thing. There is a huge difference between software that works and software that's actually secure. And it's in that gap, well, that's where the real trouble begins.
See, you could almost say our digital world is haunted. It is absolutely filled with the ghosts of past software failures, massive breaches that affected millions and millions of people. And they tell a story, a kind of cautionary tale that we all really need to understand.
And we're not talking about ancient history here. Just look at this timeline. These aren't just headlines from the past. They're like digital earthquakes that shook the internet. From Heartbleed back in 2014, which exposed sensitive data all over the web, to these enormous breaches at places like MoveIt and AT&T. These names, they represent these deep foundational flaws that let attackers just walk right in and steal data. This is a relentless, ongoing problem.
So let's try to put a human scale on this. 147 million. That's how many people had their sensitive personal information stolen in the 2017 Equifax breach. That's not just some abstract data point, that's almost half the population of the entire United States.
Or how about this one? 93 million. That's the number of folks impacted by the MoveIt breach in just 2023. And it hit everything. We're talking healthcare, finance, government agencies. The sheer scale of this is just staggering.
So this brings us to the most important question, right? Why does this keep happening over and over again? Well, the answer lies in this fundamental conflict that sits right at the very heart of how we build software.
This right here, this slide gets to the core of the entire problem. On one side, you've got functionality. It just asks one simple question. Does it work? Does the login page take my password and let me in? Yep. Okay, great. Ship it. But on the other side, you have security, which asks a completely different and frankly a much harder question. Can it be broken? Can some clever attacker just bypass that login page entirely? The failure to prioritize that second question, that's why we keep seeing those disaster headlines.
Okay, so now that we get the core problem, let's zoom out a bit and kind of map out the battlefield. Because, security isn't just one single thing, it's this whole universe of different defensive layers.
So at the very, very top, you have what's called information security, or InfoSec for short. This is the biggest umbrella. It's about protecting all information. Doesn't matter if it's a file on a server or, a paper document locked away in a filing cabinet. It covers absolutely everything.
Now, nestled right under that big InfoSec umbrella is cybersecurity. This is where we get a lot more specific and focus only on the digital world. It's all about protecting our networks, our computers, and our data from things like viruses and hackers. This is really the modern battlefield we hear about all the time.
And that brings us, finally, to our main focus today, software security. This is a specialty within cybersecurity that deals with the code itself. So we're not talking about the network firewall here. We're talking about making sure the actual apps and programs we use every single day are built from the ground up to be tough and to resist attacks.
A really simple way to think about all this is with a house analogy. Information security, that's protecting the entire house, the physical locks on the doors, the paper documents in your safe, all of it. Cybersecurity is just protecting the digital stuff inside the house, your Wi-Fi network, the smart cameras. And software security? Well, that's making sure the code running on those smart devices is solid and can't be easily hijacked by a bad guy.
Okay, so if you want to build a good defense, you really have to understand the offense. So let's flip our perspective for a minute. Let's take a look inside an attacker's playbook and learn the language they use when they're planning a break-in. First up, we have a vulnerability. This is basically a flaw, a mistake in the code or the design. The best way to think of it is like a window that was accidentally left unlocked in our digital house. It's an opening, just waiting there to be discovered.
So you have the unlocked window. Next, you have a threat. A threat is the potential for something bad to happen. It's the person walking down the street who notices that unlocked window and has a reason and the ability to climb through it. See, the unlocked window isn't really dangerous all by itself. It's the threat that makes it a real problem.
So how does the threat actually do anything? Well, with an exploit. An exploit is the specific tool or the technique that's used to take advantage of that vulnerability. It's the crowbar they use to pry open the window, or maybe it's just the simple act of sliding it open. It's the how of the break-in.
And then, finally, all of this leads to an attack. This is the moment it all comes together.
The threat uses the exploit to get through the vulnerability. The intruder is now inside the house. The system has been compromised.
So knowing all that, knowing how attackers think, how do we stop them? How do we build software that isn't just a house of cards, but a real digital fortress? Well, the good news is there's a blueprint for it.
And here is the absolute key. Security cannot be an afterthought. It just can't be something you try to bolt on at the very end. It has to be woven into the very fabric of the software, right from the first brainstorming session, all the way to the final release, and even beyond that.
And this whole process is called the Secure Software Development Lifecycle. It means you start by defining security requirements right at the very beginning. You design the software with security principles in mind, you write the code using secure practices, you test for vulnerabilities, not just for little bugs, and you deploy it all securely. It's a continuous loop, not a checklist. And one of the core principles of this whole approach is something called defend in depth. All this means is you never, ever rely on just one defense. You have layers of them. You have things to prevent attacks from ever succeeding. You have things to mitigate the damage if an attacker somehow gets through. And you have things to detect them as quickly as possible. It's kind of like having good locks on your door, but also having an alarm system and a big dog. Layers.
So, as we start to wrap this up, what's the most important thing to take away from all this? I mean, where does the responsibility for building this digital fortress actually lie?
It really boils down to this simple but incredibly powerful idea. It's not just the job of some specialized security team off in a corner. Nope. It's the job of the project manager who's defining the requirements, the developer who's writing the code, the tester who's looking for flaws. Literally everyone has a role to play.
And that leaves us with one last thought to carry with you. Every single app on your phone, every website you visit, every piece of software you rely on, yeah, it was all built to work. But the real question, the one that truly defines your safety in this digital world, is this. Was it also built not to break?